Hi everyone, welcome to the lecture series on advanced structural analysis, influence line diagram for continuous beams. Here, the ILD for movement at intermediate support. So if you look at ILD for movement at support B, so take the span AB and BC, two span continuous beam. The first span having 4 meter length, second span is 6 meter length. Then what we have to do for a movement at B, I need to apply a unit movement. So apply unit movement at B and separate these two beams into two parts. So by that, what happens? This is a separating AB span and BC span, and apply a unit movement at each of the span. This is a unit movement. This unit movement applied at the support B. So now this will have a reaction. Let us say this is RBC, because this is also AB support RBC, and this is RBA. So we have a portion AB separate and BC separate. So we should find out, the next step is to find out the reaction RA, RBA, RBC and RC. Okay. So now taking movement at A for a span AB, for AB portion, so summation of movement at A equal to 0, so gives me -1. This is the movement, right? This is, I am going towards the movement at A. That means movement at A means I am going towards LHS. This movement is the clockwise, so -1 plus RBA, which gives me anti-clockwise, which is positive, into 4 is equal to 0. So this means RBA is my 1/4. So RBA is 1/4. So RA must be equal to -1/4. Okay. Similarly, we can go for portion BC. The summation of movement at C equal to 0. So I am going towards right hand side, right? So RHS, movement at C, that means I am going towards the RHS. Clockwise, positive. So RBC gives me positive movement. So RBC into 6 meter. Then this is anti-clockwise movement, -1 is equal to 0. This means my RBC is 1/6, and that means RC is -1/6. So we should be able to draw the deformed shape now using this particular reactions. So by applying a unit movement, what happens? By this movement, these beams will deform 4 meter. So this is the deformation, like this. And this there will be deform, because longer span, so more deformation. Now if I try to take tangent, goes something like this, right? So the tangent here, so these are the theta BA, so this is theta BC. So this will be theta BA, theta BC. So total angle, included angle, will be my theta BB. So if I take a separate ordinate here for this span AB, like this, right? So taking a section from here, x here, so I have ordinate called, let us say, YBX, and the another span, the lower span, large deflections, taking x from the B support, and this ordinate is again YBX, right? Now ILD coordinate for movement at B for this portion will be my YBX by theta BB, and the next portion will be same, YBX by theta BB, right? So YBX by theta BB. This is right for different portions. This YBX will be different. Theta BB remains the same. So now trying to take the section and get the moment at each portion separately. What do we get here? Take this span portion A, B, and I have RA is minus 1 by 4, which is, that means which is a downward 1 by 4, and we have RBA, which is positive 1 by 4, and I also have a unit movement which is applied, which is 1, and the span of this beam is 4 meter. And I am taking a section X from here. So the moment here mx, x is equal to, right? So this is my section, and I am taking from the this side, A side, I am moving towards the right hand side, RHS. So RHS clockwise positive and anti-clockwise negative. So 1 by 4, this gives anti-clockwise movement. So minus 1 by 4 into x, which is minus x by 4. So this is nothing but my EI d square y by dx square is equal to minus x by 4. Integrating, what I get? EI dy by dx is equal to minus x square by 8 plus c1. Then one more time integrating, EI y is equal to minus x cube by 24 plus c1x plus c2. Okay. Now applying the boundary conditions. So what are the boundary conditions? Look at here. Here support A has a support, right? So B also has a support. So at x equal to 0, y equal to 0. That means substituting in this, C2 will be equal to 0. Then at x equal to 4 meter, so from here to here, 4 meter means at support B, so y is become 0. That means C1 is equal to 2 by 3. So now I'm getting the y here, substituting this C1, C2 in the equation. So y is equal to 1 by EI times minus x cube by 24 plus 2x by 3. This is also called YBX. Right? Now we also know at B point there is a slope because applying a moment, and also because intermediate support there will be a slope. So that slope that slope will be y dy by dx at x equal to 4, which is theta BA, which is equal to, substituting in this equation C1 and x equal to 4, I get minus 4 by 3ei. Theta BA minus 4 by 3ei. Okay, this is important. Now taking a portion BC, let us go to portion BC. Portion BC, I have RBC is upward, this is 1 by 6, and RCB is negative 1 by 6, that means 1 by 6 downward, and length is 6 meter, span length. So I will take a section from here at x distance somewhere here, and I also have a unit movement applied, which is 1. So I would like to take movement mxx. Again I am going towards RHS. Towards RHS clockwise is a positive. So 1 by 6 into x is a clockwise positive, and the one movement is negative minus 1. Okay, so this is ei d square y by dx square is x by 6 minus 1, integrating will give me ei dy by dx is equal to x square by 12 minus x plus c1. Integrating one more time, so ei y is equal to x cube by 36 minus x square by 2 plus c1x plus c2. Applying the boundary conditions, that means at x equal to 0, y equal to 0, at x equal to 0, because B has a support, then C2 will be equal to 0. Second, at x equal to 6 meter, y again 0 because there is a support C, C1 equal to 2. Right? Now, that means substituting C1, C2 in this deflection equation, so y which is nothing but my ordinate incidental x, which is bx, which is equal to 1 by ei, taking this ei this side, x cube by 36 minus x square by 2 plus 2x. And we also know at x equal 0 there is a slope which already we have. At x equal to 0, for this portion, for this portion at x equal 0, the slope is your theta BC, which is dy by dx, which is equal to, substituting x equal 0 here, C1 is 2, so directly 2 by ei. So now the slope at point B is theta BV, which is equal to theta BA minus theta BC. Theta BA we got in the previous slide, theta BA we got minus 4 by 3 ei, minus 4 by 3 EI. Theta BC I got 2 by 3 minus 2 by EI. Total is your minus 10 by 3 EI. So simply ILD is for each of the portions. For portion AB, portion BC, separate out. So MB ordinate will be YBX by theta BB. Here also MB equal to YBX by theta BB. By substituting theta BB, which is minus 10 by 3 EI, so I get ordinate here as 1 by EI minus x cube by 24 plus 2 by 3x whole divided by minus 10 by 3 EI. Similarly, this is nothing but my minus 0.125 x cube plus 2x by minus 10. This is ordinate for moment B at a portion in the portion AB. Similarly for this side, so substituting we get MB is equal to minus 1.5 x square, which is this, plus x cube by 12 plus 6x whole divided by minus 10. Now drawing the ordinate, substituting x value from 0, 1, 2, 3, 4, 5, 6, portion by portion, what we get here, let us say portion A, this is B, taking 1 meter interval here, 2, 3 or 4, 1, 2, 3, 4. Similarly portion BC, 1, 2, 3, 4, 5, 6, because it's a 6 meter. So ILD ordinate will be something like this. So this is very important. So at every 1 meter interval, I will get the vertical ordinate. So we need to see corresponding portion to get the ordinates. So here, so by substituting the ordinates, I can get the ordinate. So this will be a ILD ordinate, and this is a ILD for movement at a B, which is intermediate support. Thank you.